Hello and welcome to a new chapter of mathematics on differential equation. Today being the first lecture on differential equation, we are going to begin with the basic definition of a differential equation. Later we are going to discuss orders and degrees of a differential equation. After that we are going to find out how to form a differential equation, and finally we are going to conclude this segment on differential equation by discussing a numerical problem that would be based on formation of a differential equation. Starting with the basic definition of a differential equation is basically an equation that involves independent and dependent variables and derivatives of dependent variables. For example, we are going to consider a differential equation which is given as x square dy by dx square plus 5 dy by dx equal to 7 x square y square. Now, as is very much evident from this differential equation, we can see that this differential equation contains dependent and independent variables and the derivatives of the dependent variables. Thus, this is a differential equation. Next, we are going to discuss about orders and degrees of a differential equation. So, starting with the order of a differential equation, the order of a differential equation is the order of the highest derivative occurring in a differential equation. Next, moving to the degree of a differential equation, the degree of a differential is the degree of the derivative of the highest order occurring in a differential equation. Next, we are going to consider an example of a differential equation in order to evaluate its order and degree. Now, here we have an example which has its elements as x square dy by dx square plus 5 dy by dx equal to 7 x square y square. Now, in order to find out the order, we need to find the order of the highest derivative occurring in it. Since here the highest derivative occurring is dy by dx, therefore the order of this given differential equation is 1. In order to obtain the degree of this given differential equation, we are going to find the degree of the derivative of the highest order occurring in this differential equation. Now here, since the highest degree of derivative dy by dx is 2, therefore degree is 2. Next, we are going to find out the solution of a differential equation which gives the relation between the variables not involving the differential coefficients such that this relation and the derivatives obtained from it satisfy the given differential equation. Now we are going to consider an example where we are going to prove that the given equation is the solution to the given differential equation. Now for this we are going to consider a differential equation and the solution to a differential equation which is given as y equal to a cos x plus b sin x. This equation is labeled as a. Now a is the solution to the differential equation which is given as d square y by dx square plus y equal to 0. Now this equation has been labeled as equation number b. Now in order to prove this, what we need to do is we need to differentiate equation a with respect to x twice, since we have two arbitrary constants here. Now differentiating a with respect to x, we have dy by dx equal to minus a sin x plus b cos x. Now this has to be differentiated again, thus we have d square y by dx square equal to minus a cos x minus b sin x. Now as we can see that in equation number a, y is equal to a cos x plus b sin x. This gives us the value of d square y by dx square equal to minus y. This can be rewritten as d square y by dx square plus y equal to 0, which is same as that of the differential equation which has been labeled as equation number b. Thus we have proved that equation number a, which is y equal to a cos x plus b sin x, is the solution to equation number B, which is d square y by dx square plus y equal to 0. Next is the formation of a differential equation. Now from the previous example, it is clear that a differential equation can be derived from its solution by the process of differentiation and other algebraic process of elimination, etc. On this account, solution of a differential equation is also called as its primitive. And finally, we are going to deal with the problem that requires formation of a differential equation whose solution has been given. In this given problem, we have to form a differential equation whose solution is given as xy equal to aex plus b e power minus x plus x square, where a and b are constants. So we have an equation which is given as xy equal to a e power x plus b e power minus x plus x square. To form the differential equation, we need to differentiate this equation, which is, let's say, labeled as equation number 1. Now we need to differentiate this equation with respect to x twice, since we have two arbitrary constants, that is a and b. So differentiating equation number 1, once we have x dy by dx plus y equal to a ex minus b e power minus x plus 2x. Now we are going to differentiate this equation, which is labeled as equation number 2 again, and thus we get x d square y by dx square plus dy by dx plus dy by dx equal to a ex plus b e power minus x plus 2. Now eliminating a and b from equation number 1, 2 and 3, we have a e power x plus b e power minus x equal to xy minus x square. Now we are going to substitute this equation, let's say, which is labeled as equation number 4, in equation number 3, and thus we obtain the equation x d square y by dx square plus dy by dx equal to xy minus x square plus 2. Now this equation, which is labeled as equation number 5, is the differential equation whose solution has been given in the problem. With this, we conclude our first lecture on differential equations.